Alright, for the second part of this video, what we're going to do is just determine how to find the equation of an inverse if you're given a function or a relation. And then we'll do a couple of examples, and then the last part of the video I'm just going to do a more complicated example using more than one function. So there's 3 steps when you're determining the equation for the inverse relation. Okay, and I just have an example over here on the right, so we're just going to change it as we go. So the first thing you want to do when you're writing the inverse of a relation is make sure the equation is written in xy notation. Okay, so over here on the left I have y equals x plus 3, so that's perfect. It's already written with a y instead of an f at x. Step 2 is to interchange the x and y, and that also interchanges the domain and range. So what I do is I take my equation here, and instead of writing y, I write x, and instead of writing x, I write y. Okay, step 3 is to solve for y. So this equation is pretty straightforward. We have to subtract 3 from both sides, so we have x minus 3 equals y. Okay. If the inverse is a function, you rewrite it using this new notation we learned, which is the inverse of f, or f inverse. So if this here, this last part here, is a function, you finish off writing f inverse equals. So this is a line, y equals x minus 3. So I would finish this off using f inverse equals x minus 3. Right? So we're just changing it back into function notation. But now we have to say f inverse because it is the inverse of the original equation. Okay, so we're going to do a couple of examples. So we want to find the equation of the inverse, and then once we found the equation, we want to state whether or not the inverse is a function. So example A, okay, it's already in xy notation, so we switch the variables around. So now we have x equals 3y plus 2. Okay, so I replaced my y with x and my x with y. And now I want to solve for y. So we're going to subtract 2 on both sides, and then divide both sides by 3. Okay? If this is a function, then we want to write it in function notation. So we take a look at it. Y equals x minus 2 over 3. That's a line, right? We just have an x and then another term with just a number. So this is a function. It's a linear function. So we can write our inverse in function notation. So f inverse equals x minus 2 divided by 3. Okay, same as for example B, except for example B, we have to start by changing it into xy notation to get rid of the f at x. Then we swap our variables. And then we solve for y. So in this one, we multiply both sides by 4, and then subtract 3 on both sides. Okay, and then we check to see if it's a function. So y equals 4x minus 3. Yes, that's a function. It's a line. So what we can do is we can write it in function notation. Okay, and then we're done. So just a couple of notes. You'll notice both of these examples are linear functions, so they both start with linear equations. And then when we found the inverse, both answers are also functions. Okay, so we'll do a couple more examples, and then we'll have a slide at the end that sums up everything from these examples. Example C is already in xy notation, so we're going to switch our variables. So we have x equals y minus 4 squared. To get rid of the squared, we have to square root both sides. So we have plus or minus the square root of x equals y minus 4. And then we want to add 4 to both sides. So plus or minus x plus 4 equals y. Right? Is this a function? You have to think about what the graph is going to look like. So if you take a look at this, it has a root sign, so it looks like a root function. But for the root function, if you remember, it looks like this. We only had the positive part of root. Okay, we didn't write plus or minus. We only wrote, or we don't even bother writing it, a plus sign in front of the root. So the root function only has a positive square root of x. In this equation, we have both positive and negative. So this is not a function. So we're done. We leave it like this. We can't write it in function notation. Example D, first thing we'll do is change it into xy notation. Now we swap our variables. We switch x and y. Okay, we solve for y, so add 2 to both sides. We square root both sides, so that means both the x and the 2 are under the square root sign. And then we subtract 3. So we end up with plus or minus root x plus 2, and then minus 3 equals y. Okay, and the same as the last example C, we have the plus or minus root, which means this is not a function because we have positive and negative parts of the graph. So it's going to look like an entire sideways parabola rather than just half a parabola, like the root function. Okay, so both of these examples, if you look at the starting equation, so here and over here, those are both quadratics, right? They both have x squared in them. If you look at the inverses, okay, both of them have plus or minus square root signs. So neither of the inverses are functions, but both of the starting equations are quadratic functions. Okay, so to sum everything up, the inverse of a linear function or a line is always a function. Okay, the only exception to that rule is if we start with a horizontal line, the inverse is going to be a vertical line, right? And a vertical line is not a function because it fails the vertical line test. Okay, and the inverse of a quadratic function is never a function, right? Because if you think about it, okay, our base parabola looks like this. And if I do the inverse of a parabola, it's this half as well as the negative half. Okay, so if I have the inverse of a quadratic function, I'm never going to get a function.